So this is the answer to number 5, and hopefully we were okay to here. So we're asking that question each time, what do I need to do to turn that into that? And that's what I would multiply the denominator by, so therefore I have to multiply the numerator as well, and I'm sort of ignoring the denominators. What haven't I got there that I have got there, so that's why I need the x and the x minus 2, and similarly there. So you're then asking what value of x would make each of the brackets 0, and of course one of the brackets isn't a bracket at all, just contains x. So I started by substituting in x is 0. That becomes 2. That disappears because 0 times anything is 0. That disappears, so you're just left with 0 plus 1 and 0 minus 2. So that's where I get the minus 2 from. And then I use my calculator for the rest because it's just too complicated. So I typed in minus a half equals arrow x, so it was stored in x. I then typed that in, and it gave me 7 over 2, and then I changed it to 2/3, and it gave me minus 70 over 9, and I did the same for here as well. So when x is minus a half, that term becomes 0, so that disappears, and that term becomes 0, so that disappears. So you've just got to work this out. So you've got minus a half multiplied by 3 lots of minus a half minus 2, and I just got my calculator 0. And it just said, the question just said, what are the values of D, E, and F? So I haven't even bothered rewriting this. I've just said, right, that's what D, E, and F are. So, okay with that? George, you're looking furrow-browed, is that? Okay, can I give you another one then? And my question is, why does this one provide us with a little bit of a quandary when we come to set it up initially? Okay, so let me write it up. Oh, sorry, for those of you at home, when you have the bracket 3x minus 2, if you couldn't work out what value of x to use, remember we're just asking when does it equal 0, so that's where I got the 3 over 2 over 3 from. I'm trying to dry the board so when I write on it, rubbish pen. Right, so here's the next one then. This is the one I want us to do. So the difference here is that one of the factors in the numerator is a repeated factor, it's squared. So yeah, okay, I'm going to say, right, let's it's just going to be this, isn't it? Can anyone suggest what is wrong with that? Well, the problem is this, I'm trying to sort of work out what the question was that gave me this is the answer. This is hokey-cokey, isn't it? We did the adding algebraic fractions on Monday or Tuesday, and now we're working backwards. I don't know whether or not there might have been a term with just x minus 1 in the original question. Because I've got x minus 1 squared, I don't know whether it came from just an x minus 1 squared or whether there was an x minus 1 as well. So what I have to do when you've got a repeated factor is I have to hedge my bets. And I have to say, okay, it's that plus that. I'm covering both bases, belt and braces. And it might be that one of these is 0. Well, actually, this one won't be 0, but it might be that one might be 0, in which case I was being unnecessarily cautious. But I've got to put it in there. So when you've got a repeated factor, something squared, when you decompose it into partial fractions, you've got to have the factor on its own and the factor squared, because we don't know whether the original sum, which gave us this as an answer, came from just that, or whether it had that as well. What are you going to say, Jacob? Sure? So can you just see if you can construct the next line for me? You know, what's the 11x squared plus 14x plus 5 equals, what's that next line going to look like? Okay, so what have I got here that I haven't got here? Well, I need another x plus 1 and a 2x plus 1. Remember, we're just ignoring the denominators. They are there, but we know we're going to multiply through by them.
I thought you get the denominators from the other two fractions and times.
No, this is the denominator I'm always referring to. So what do I need to do to turn this into this? I need another x plus 1 and another 2x plus 1. And then B, what do I need to do to this to turn it into this? I just need a 2x plus 1. And C, I need an x plus 1 squared. So that's my next line in the problem. This method has a different, a second problem associated with it. So I'm now going to substitute values in. I'm going to substitute in minus 1. Assuming we're using this, I've assumed today we're going to use the substitution approach. You've got the equating approach up the sleeve as well. I'm also going to substitute in minus a half. But that's two values I substitute in. I've got three missing values. So what you have to do is you have to do a third substitution. This is going to get you so far, but we're then going to have to substitute in a third value. Go through those two first steps for me to begin with. Substitute in minus 1 and minus a half, and then we'll see how we deal with the third step. Okay? So I put minus 1 in, which made that bracket 0, so that term disappeared, and that bracket 0, so that term disappeared. And when x is minus 1, you get minus 2 plus 1, so that's minus 1 times b, blah, blah, blah. I then made x equal to minus a half, so this term disappeared, and that term disappeared, so I was just left here with this term. Minus a half plus 1 is a half squared is a quarter. So C is 3. So I've only worked out B and C. So, I mean, there's a couple of ways of doing the next bit, but I think the easiest way is just to substitute in a third value and pick something easy. So I'm always either going to use 1 or 0. Now, you know, if I'd already used 1, I'd use 0. I'm going to use 0. So if I substitute in x is 0, I get 5. And I'm going to get all three terms. That's got to be careful. So I've got 0 plus 1 and 0 plus 1. So that's 1 times 1. So that's just A. And 0 plus 1. So that's B. And 0 plus 1 squared. So that's C. But I know what B and C are. So B is minus 2 and C is 3. So I get 5 equals A plus 1. So A is 4. So when we've got a repeated root in our denominator, it has to feature twice in our partial fraction decomposition. Once on its own and then once squared. And that just presents us with a slightly awkward issue when we come to substitute values. If we're using substitution, equating doesn't have the problem, but it just, as always, requires a lot of multiplying out. So you can use equating. You would equate x squareds, x's and numbers. And we get there. Now there is loads of good practice, so I'm going to propose we try 3 now on page 13. And I'd like us to have a go at number 2 first, followed by number 1, followed by number 4. But page 13, every question on there is a a good one. So you know, if you want more practice, then I recommend that you have a go at more of those. But yeah, in a minute we'll do question 2, then we'll do question 1. So for 2, it doesn't matter what order you put your A, B and C in, and that's why exam questions nearly always give you an order, but I don't think question 2 did. It did not. So I've done like the first 2 lines. You needed, because x plus 1 was squared, you needed it on its own and squared. So that's what the next line looks like, and now you're hopefully going to substitute in 1 and minus 1 and then a third value. And over here, just you know, watch out, that is a repeated term. X squared is a repeated term, so you do need it on its own and squared as well as that. And in fact, the question prompted you in question 1 to do that. And hopefully with that one, you're going to substitute in 0, x is 0, and x is minus 1, and then one other value. See how you get on. Yeah, so I substituted x is 1, got c is minus 4. Were you in agreement with me there? Minus 1, I get b is minus 2. This is really fiddly when you've got 1 and minus 1, so you just got to use your calculator. You know. So I've got 2 values. I'm now going to use 0. So so that comes as minus 5. So I've got 0 plus 1 and 0 minus 1. So that's 1 times minus 1. So that's minus a. I've got minus b. And I've got 1 squared, which is 1, so that's plus c. But I know what c is. Oh, this is nice, isn't it? So I've got minus a, minus b. Well, b is minus 2, so that would be plus 2. Take away 4. So I'm going to add a to both sides and add 5 to both sides. So I get a is 3.
Yeah, the book has it as minus 3.
Minus 3.
I've got it as 3.
Right, hang on a minute. I'm going to pause. Right, yeah, the print version of the book has got the answer wrong. So it's the online version is fine. The PDF probably means that's wrong. Might be right. So A is definitely 3 there. And then with the second one, having substituted in x is 0, which made that disappear and that disappear, and x is minus 1, which made that disappear and that disappear, I'm going to use x is 1 for my third value, so I'm pretty much always going to either use 0 or 1. It's an easy value. So I've got, and yeah, please use your calculator, but I've got 3 plus 1 plus 1. And that's going to be 1 times 2, so that's 2a. That's going to be 2b. And that's going to be c. But I know what b and c are. B is 1 and c is 3. Oh, so a is 0 in that case. Has anyone else got 0? Yeah. There we go. So there's me saying I've never come across one where a is 0. So in that case, in question 1, I was being overcautious. I didn't need that term there. It just came from that originally. There we go. Right. Have a go at finishing number 4. And the whole of that page is full of really good practice. So see if you want to do it. Do it as much as you want. I'm going to pause, and when I come back, we'll take it on a step of difficulty. I've just noticed that in question 2 in the book it says D, E and F. Sorry about that. So it doesn't matter, does it? So the other thing it says in question 2 is x can't be minus 1 and it can't be 1. And you might think, well, hang on a minute, I've just made it 1 and minus 1. Well, no, what they're doing is they're referring to the original question here, and that's because if x is 1, or if x is minus 1, the denominator would become 0. We'd be dividing by 0. Bad maths. However, having done perfectly valid algebra to get from there to there, and this isn't the original question, this is a development of it in order to work out the decomposition. I can substitute what value I want into that. So it's just saying in the original question you're not allowed those values. You can ignore it basically. It's just them making their question valid, that's all. it doesn't mean you can't use those values there. Thank you, that's a really good question. So for page 13, question 4, they give you the clue in the question that you need to start by factorising the denominator. And it was a fairly sort of basic factorisation, but it gave us a repeated root. So we get to there. So that's the first line of your method. I'm not going to go any further, but just to remind you, you need to substitute in x is 0, x is 1, and then one other value. So I'm going to use probably x is 2 in this case, because I've already used my go-to 0 and 1. Right, so if we can now have a look at page 14, example 11, which sort of looks a bit like the ones we've been doing. We've got a algebraic fraction, rational function, and we've got A's, B's and C's, or even a D in this case. So George, why is it I know that this question isn't a partial fraction question?
Because the power on the top is two more than the bottom.
Yeah, we've got a problem with our orders here, haven't we? This is not a partial fraction question, because partial fraction questions require an order of the numerator one less than the denominator. So I'm not going to be able to partial fraction up this problem. So this is a different thing. And the good news is we've met this before. This is algebraic long division. So here I'm being asked to take an expression and divide it by x minus 3. Now, I'm fairly sure, although it may be a little bit rusty, hopefully you revised it for the mock, fairly sure you can do that. What we might be a little bit fuzzy about is how we take our answer and put it in this form here. So go and see if you can have a go at doing algebraic long division for that question. And you've got one thing to remember. Remember, algebraic long division needs a term for every power of x. And if you look at the numerator, there is no x term. So you've got to put a dummy x term in your under your bus stop. So it's going to look like x cubed plus x squared plus 0x minus 7. So I'm going to leave the video running and get you to have a go at that.
Just I'll touch on the first bit on here. Will the first term that I bring down be the 0x? Do you know what to do after you do the
Right, yes, I see what you mean. I'm gonna do it rather than answer that. So you've got an x squared there?
Yeah.
So we've got x squared times x is x cubed, should always be the same. X squared times. We then do our subtraction, and this is where you've got to be careful.
4x squared.
That minus that, 4x squared. So yes, you are correct. The first thing you bring down is the 0x. Yeah. Hope that's visible on the camera. So I'm going to write it out again. Yeah, remember the reason we get 4x squared is we're doing x squared minus 3x squared. So that gives you this form.
At the end of the long division, should you get a 0 at the end?
No.
Not always.
Should be a remainder. Well, it depends. If this was a factor of this, then you wouldn't get a remainder. But in this question, there is going to be a remainder, and there's a clue in the form of the question which sort of reassures us that we're going to get a remainder. Right. So I got to here. So having asked how do I get from x to x cubed, which was x squared, I'm now asking how do I get from x to 4x squared, so that's a 4x. I do my multiply. And this take away this, always 0. 0 minus 12x is 12x. Bring down the minus 7. So third and final question, how do I turn that into that? Multiply by 12. 12 times minus 3 is minus 36. I mean, do you remember when we first did this, how puzzled and confused you were? And actually from the mock, this was done really, really well. Minus 7 minus minus 36, that's minus 7 plus 36, so that's 29. So we've got a remainder, 29. So if I use a sort of analogous maths sum, 15 divided by 4, well, I can get 3 whole 4s out of 15, and then I've got 3 left over. And what that actually means, because I'm dividing by 4, I get 3 whole ones and 3/4 of another 4. And so what it means in this case is, what do you get if you divide that by that? Well, you get x squared plus 4x plus 12. So that's what my a, b and c are. So I've got 1x squared plus 4x plus 12, and my remainder is 29. 29 out of x minus 3. It doesn't really make sense, but that goes there. And so this question is not a it's not a partial fraction question at all. It's just a long division question. It's a long division question. How are we doing at time? 1 minute past. Okay, yeah. Let's just do example 12, which is a slightly different way of writing the same question. So have a look on page 15 at. We're going to do page 15, example 13. Sorry, page 15, example 13. We'll do example 12 next lesson. So same thing, you've just got a bigger division sum to do. So at the bottom of page 15, example 13, I'm going to leave the video running, but you may choose to pause and look it up.
Just so we don't have a dummy value.
So you need a
Next square term as well.
You need an x squared term in the numerator. That's right. Well spotted.
Do you have to separate the x squared plus 2x minus 3 into 2 brackets, or can you just divide by the whole thing?
Divide by the whole thing. Yeah. The polynomial division works as long as. So it only works if the order of the numerator is greater than the order of the denominator. It won't work if it's the other way around. But there is a subtle difference in the way the answer looks compared with the previous one, isn't there? Don't forget your dummy value, as Jacob has pointed out. We need a dummy x squared value this time. Okay, so how do I turn x squared into x4 multiplied by x squared? That gives me this. Do my subtraction, got to be really careful, particularly here, 0 minus minus 3. So now how do I turn x squared into minus x cubed? Minus x cubed minus 2x squared plus 3x. 3x squared minus minus 2x squared. X squared take away 3x squared. Sorry, 2x. X take away 3x. That's what I said. And then lastly, how do I turn that into that? So that gives me 5x squared plus 10x minus 15. 2 take away 10, sorry, minus 2 take away 10 is minus 12x. Be really careful here, minus 10 minus minus 15. So this time my remainder is not a number, it's an order 1 expression. So my answer, I'll fill in my answer, I've got 1x squared minus 1x plus 5, and then I've got minus 12x plus 5. And I could replace that with a minus or just put plus minus. It doesn't really, actually no, sorry, because that's minus but that's plus. So I'm going to put plus and then leave that as a minus. How did I know that the remainder in this case was going to be linear, order 1? Well, the remainder is always one order less than the number you're dividing by, the divisor, the denominator. So the first example we did, we divided by something of order 1, so we got an order 0 remainder. And now we're dividing by something of order 2, so we got an order 1 remainder. Okay, page 13 if you want more practice of the repeated root partial fraction decompositions, and then we'll move this on next lesson. I will do that video on Tuesday because I think it's better in the other room with the light. So take care everyone.